All right, what we're going to do here is summarize what we've gone over in absolute value inequalities and equations because there's quite a bit involved here, and a lot of students have difficulty in this section. So let's recap what we've covered. What we have is these three patterns. We've got an absolute value equation. If you have the absolute value of something equals k, then the solutions are, or this means, x will equal k, or x will equal negative k. Okay, so if I see an absolute value equation, I follow that pattern. The second pattern that we had was an absolute value less than k. If we have an absolute value less than k, then this means x is between negative k and positive k. Like that. And the third pattern that we have is if we have an absolute value greater than some number, positive number k. This one means x is greater than k, or, this is an or statement here, x is less than negative k. Okay, so those are the three patterns, and depending on what you're trying to solve, you would use one of these patterns. So let's do an example of that. For example, absolute value 2x plus 5 equals 7. Now this is an absolute value equation, so I'm going to use this pattern right here. And it tells me this will equal 7 or it will equal negative 7, so I'm going to write that down. 2x plus 5 will equal 7, or 2x plus 5 will equal negative 7. Solve each one for x and you get your two solutions. 2x equals 2, x equals 1. And then over here we've got 2x equals negative 12, divide by 2, and what do we get? Negative 6. And notice these are equations, so it's just two numbers. You don't do any of the graphing or anything. The solutions are 1 and negative 6. The two solutions to the absolute value equation. Okay. Next example. Let's say we have absolute value x plus 1 is less than or equal to 3. This is an absolute value less than or equal to 3, and so the pattern that applies here would be this one. And so I'm going to do what it says. This x, which is actually this x plus 1 for me. This in here will be between negative 3 and positive 3. That's the way I'm going to write it. This x plus 1, right in there, is stuck between this 3 and negative 3. Okay, that's how we follow the pattern. Now I just solve for x. Like that. And those are our solutions. On a number line it would look like this. Oh, let me fix that. That means everything between negative 4 and 2 is supposed to be shaded. Brackets. And on our interval notation, that we bracket negative 4 to 2 bracket. And so those are the solutions to the inequality. All right. Another example. absolute value x plus 3 is greater than 4. Now this one is absolute value greater than, and so the pattern which applies is that one right there. And so I'm going to follow this, and that would be x plus 3, this part right here, is greater than 4, or this part, x plus 3, and I'm following this pattern right there, less than the opposite, negative 4. That's how the pattern goes. Now I just solve for x. Now it would give me x greater than 1. This would be x less than, what would that be, negative 7. X less than negative 7. And now this is an OR compound inequality, so I'm going to, I like to graph these on a number line. Negative 7 to 1. And greater than 1 are these numbers. Less, that's greater than 1 are these over here. Less than negative 7 are these. It's an OR statement, so you keep everything that has been shaded, which actually is this and this. So those are solutions. In our interval notation, that would be negative infinity to negative 7, union 1 to infinity. There we go. Okay. All right, let's do another one. Absolute value 2x plus 5 is equal to one. All right, this is an absolute value equation, so this is the one that works. 2x plus 5 equals 1, or our 2x plus 5 will equal negative 1. I follow the pattern. Solving for x, this will give me x equals negative 2. And if I solve this one, x equals negative 6, negative 3. Yeah. Our two solutions to this absolute value equation are negative 2 and negative 3. Just like that. Absolute value 2x minus 1 is greater than or equal to 3. This is an absolute value greater than, and so this is our pattern that we're going to follow. 2x minus 1 is greater than or equal to 3, or, following what it has written down here, 2x minus 1 will be less than or equal to negative 3. Solve each part for x. 2x greater than or equal to 4, x is greater than or equal to 2. Over here we end up with x is less than or equal to negative 1. Okay. Now this is a compound inequality with an OR, so I'm going to draw my number line. And I'm going to do some scratch work. Greater than or equal to 2. Less than or equal to negative 1. It is an OR statement, so if you recall, you just keep whatever's been shaded. So my work just looks like the answer here. And in our interval notation, the solution would be negative infinity to negative 1 bracket, union bracket 2 to infinity. There we go. Solved. Let's do one more of these. Let's say we have an absolute value of 3x plus 1, and I've also got a minus 2 here, is less than 3. Let's try that. Okay. I have a number on the outside of the absolute value, so really what you're going to want to do first is you're going to want to move this over. Don't leave it there. Got to move it over first. So this is actually absolute value 3x plus 1 is less than 5. Okay. So anytime you have a number on the outside of the absolute value, would move it to the other side. Now this is an absolute value less than, so this is our pattern we're going to follow. 3x plus 1 right here is stuck between negative 5 and positive 5, just like that. I am now going to solve for x, so I'm going to subtract 1 here. Negative 6 less than 3x less than 4, and then we divide each part by 3, and let me write it up here. X is going to be between 4/3 over here, and over here is a negative 2. And those are solutions, all the numbers between negative 2 and 4/3. On a number line, it would look something like this. Let's see, 4/3 would be right about here, or 4/3 in there. Shade everything between negative 2 and 4/3. Just like that. In our interval notation, that would be parenthesis negative 2 to 4/3 parenthesis. And there's our solution. Okay, so I hope that those examples help clear up the different types of absolute value inequalities we have here, the three main types. A couple other things here. And here's one of them. Let's say we have absolute value 2x plus 1 equals absolute value x plus 5. Okay. We haven't seen one of these yet. This is an absolute value equation, but each side is an absolute value on it. And what I do to solve this is I really just treat it, I really think of it as this one. It's absolute value equal sign equation. I'm going to do it this way. I take this side, and it's kind of just following the pattern here. 2x plus 1 will equal x plus 5. In other words, just write it without the absolute values. Or there's another possibility. This side, 2x plus 1, could equal, notice the pattern here, negative k. So it's negative this, or opposite of x plus 5. Just make sure that you use parentheses like this right here. Negative parenthesis x plus 5. So here this is kind of like our k, and then over here this is negative k. Now if I solve each one of these equations, I will get my two solutions here. So let's do that. Over here, subtract x from both sides. We get x plus 1 equals 5. Move the 1 over. X equals 4 is a solution. Over here, you've got to distribute that negative sign, like that. Let's see, 3x will be equal to negative 6. And if I did that right, that should be x equals negative 2. Negative 2. And so our two solutions to this absolute value equation is negative 2 and positive 4. Okay, so that's what you do if you have an equation with two absolute values in it.